What if the most important clues about Mars didn't come from rovers or landers, but from rocks that crash landed on Earth? For decades, NASA has explored Mars from orbit and on the ground, but the red planet has secretly been sending us samples all along. These meteorites carry stories of ancient volcanoes, buried ice, and violent impacts, but there's one mystery scientists are only now solving. Where on Mars did they come from? In this video, we'll trace those space travelers back to the craters that launched them and uncover what they reveal about Mars's past. Since the mid-1970s, NASA have sent a variety of landers and rovers to the surface of Mars. They have studied a range of Martian rocks remotely, but none of our probes has yet to return any samples of Mars for study here on Earth. Fortunately, nature has stepped in and has provided us with about 200 meteorites that have been identified as Mars rocks that have fallen to Earth. These specimens, blasted off Mars' surface by asteroid impacts, bring with them invaluable stories of Mars and its history. But as wonderful as they are, the stories these rocks have told us are frustratingly incomplete. We have been left to guess just which locations on Mars these individual rocks came from. We have their stories, but we have been missing the critical context of where these stories happened, what the very important settings for these stories were. Mars is covered by many millions of impact craters. Finding which of these might be sources for the meteoritic samples NASA has seems like an overwhelming task. However, we do have some clues we can work with. In studying the meteorites that have come from Mars, we see that they are not a random population. Instead, they seem to be organized into 10 distinct groups that share similar ages and compositions. This tells us that these rocks came from 10 different impact events on Mars, and they were ejected from 10 different impact craters. That certainly helps. It tells us how many craters we're looking for, but which 10 craters out of all of the millions are our source craters? By breaking light reflected off of rock surfaces into spectra, NASA's scientists can try to match the compositions of Martian meteorites and impact craters on Mars. This can narrow our search a little bit, but this process is complicated by the fact that individual craters may cover a variety of terrains and rock types. Let's take a closer look at each of these fascinating craters. Tooting crater lies in the Tharsis volcanic province on Mars. The crater measures about 28 kilometers across and 1,500 meters deep. The crater is typical of a class of craters known as rampart craters. These are surrounded by thick, pasty impact blankets, indicating that they formed in areas with significant amounts of subsurface water or ice. Tooting is just to the west of a gigantic debris flow extending from Olympus Mons, Mars's and the solar system's tallest volcano. Tooting has been identified as being the probable source of a group of Martian shergottite meteorites that includes the Tissint meteorite that landed in Morocco in 2011, estimated to have formed on Mars about 574 million years ago and to have been ejected from Mars about 1.1 million years ago. Domoni Crater is located in the northern part of Tharsis. It is about 12 kilometers across and 1,000 meters deep. It also is a clear example of a rampart crater. Domoni is the probable source of the augite-rich shergottites, whose rocks originally formed on Mars about 2.4 billion years ago and were blasted from Mars about 1.2 million years ago. Chakpar crater is located on the lower northeast slope of the great volcano Ascraeus Mons in Mars' Tharsis volcanic province. Like Tooting and Domoni, Chakpar is a very well-defined example of a rampart crater. The crater measures about 20 kilometers across and 1,200 kilometers deep. Chakpar is the probable source of shergottites like the elephant moraine 7901 meteorite found in Antarctica in 1979-80 with a formation age of 173 million years ago, and which was ejected from Mars about only 600,000 years ago. Corinto crater lies in the Elysium volcanic province of Mars. Corinto measures about 13 kilometers across and about 1,000 meters deep. Like the other craters NASA has examined so far, Corinto is clearly a fine example of a rampart crater. However, it is especially distinguished by having one of the most extensive systems of ejecta rays and secondary craters on Mars. Corinto is the probable source of the family of shergottites that include the Zagami and Los Angeles meteorites. These rocks are estimated to have formed on Mars between 170 and 180 million years ago, and to have been ejected from Mars about 2.9 million years ago. Kotka crater is located in the western portion of the Elysium volcanic province of Mars. It measures about 40 kilometers across and 1,800 meters deep. Its ejecta blanket is not nearly as prominent as what NASA teams saw in the other craters they have examined here, but it does exhibit complex, multiple layered structure similar to what they see in more clearly defined rampart craters. Kotka has been identified as the probable source of the knackite and chassignite types of Martian meteorites, with formation ages of 1.34 billion years ago and ejection ages of 1.2 million years ago. As NASA find more Martian meteorites and make improvements to our abilities to measure surface compositions on Mars, estimate ages of craters on Mars, estimate the lengths of time meteorites spent in space, and estimate crater sizes from the shocked material they find in meteorites, they can hope that the level of certainty for these 5 candidate craters will increase to an even higher level, and that identifications will be made for the remaining groups of Martian meteorites. Being able to tie the samples they have from Mars with specific locations will provide us with the context to better understand the stories that these rocks are telling us. It will allow us to better calibrate the chronology of Mars's history as it changed from a wet, possibly habitable world to the frozen desert that it is today.